All right, so go back to the book. Let's go to page 697. And we're going to go ahead and do that. This is kind of a long problem. We're going to look at question 45. I'm going to draw the figure for you anyway, so I won't have the nice storm clouds in there, but I'll draw it for you. Let's read through this. But since we'll have the figure, that's going to be the most important thing. All right, so it says a cruise ship maintains an average speed of 50 knots in going from San Juan, Puerto Rico to Barbados, West Indies, a distance of 600 nautical miles, okay? To avoid a tropical storm, the captain heads out of San Juan in a direction of 20 degrees off a direct heading to Barbados. The captain maintains the 15-knot speed for 10 hours, after which time the path to Barbados becomes clear of storms, okay? Through what angle should the captain turn to head directly to Barbados? All right, so basically starts out, would have been better for him to go a direct route, but what happens? It starts raining, he's got to dodge it, and then we need to figure out what's the fastest way for him to get back on track, basically. All right, they do give us a figure to build on. So they gave us, let me move down a little bit. So here's what I'm going to redraw. So you can see he starts out, heads out 20 degrees. See, he should have just gone straight on through. Do you guys see it? But, of course, the rain causes him to veer that 20 degrees off track. Does everybody see it? And then we've got to find that dotted distance going back to Barbados. Okay, so let's redraw that. I wish I could just copy it, right? That'd be so great, but... All right, let's see here. Okay, so here's San Juan. And directly over here is Barbados. And we know this is 600 here. And he veered off 20 degrees. Went out a distance. I need to figure out how much that distance is. And now we've got to figure out this part. That's what we're looking for. And then right here, they're marking an angle. So we got to figure out, here's the ship right here. We got to figure out what that, do you guys see that theta I just highlighted? Does everybody see it? That's what we need to find. We need to figure out how much he needs to turn right to start heading back towards Barbados. Do you guys see that? Okay. All right. All right. There was some, I got to go back because it said it maintains an average speed of 50 knots in going from a distance of, to avoid a tropical storm, this is the part I need. The captain heads out in a direction of 20 degrees off the direct heading to Barbados. The captain maintains the 15-knot speed for 10 hours. That's the part I need. Because I know if he went, we know distance is what the rate times what? Time. He was going 15 knots, right? For how long? 10 hours. So he went 150 nautical miles. Does that make sense to you guys? So what that tells me is this is how much? 150, right? Before he decides to turn back, right? Okay. How's everybody doing with that? All right, the first thing I want you to see, I've been saying this, but now you actually get to visually see it. I know I'm going to use law of cosines. And the way I know it, do you guys see I have two sides? And then squeezed in the middle, what do you have? The angle. That's how you know it's law of cosines. Anytime the angle's squeezed in between the two sides, it's law of cosines. I know I'm ultimately after theta because it asked me through what angle should the captain turn to head directly to Barbados. So ultimately what I want for part A is I'm looking for that theta I label, but I'm going to have to do some work to find it. I'm going to start going ahead and labeling some stuff. I'm going to call this angle C, which would make this side C. You can label it differently. I'm going to call this little b, and I'm going to call this angle A, which would make this little a. So just go ahead and label it like I've got it labeled there. So now I'm thinking, ooh, I really need angle C, right? Because if I can get angle C, I can get theta. Do you guys kind of see it? So I'm like, oh, okay, that's what I need to get. The problem is I don't think I can get it just yet. I need to get, what can I get? I think I can get B. Yeah, and once I get B, then I'll be able to open the door up to get what I need, okay? All right, so let's see. What do we need for B? Law of coastline says B squared is A squared plus C squared minus what? 2AC cosine of what? B, right? Do I have all that? I have A, I have C, and I have angle B. Does that make sense? So I can get B. So go ahead, take the square root and start filling it in. A, we said, was 150. C was 600. And then the, what was B? B was 20. Do you guys see it? All right, I'm going to clean this up a little bit on the inside. I'm just plugging all this into my simple calculator. $461.9. Okay. Okay, I just told you guys not to switch to law of sines, and I'm like, oh, I think it might be easier to switch to law of sines. But if you want to, we can stay with law of cosines. Normally that would be the case. The only thing is with my figure, I already see that A is acute. I can see it's an acute angle, so I would probably be okay. But let's stay with law of, I'll actually work it a little differently, and we'll just stay with law of cosines. All right, I'm like desperately trying to get at angle C. Now, the only thing is, this is why I was thinking, oh my gosh, I can use law of sines now because I have C and C. Does everybody see it? And then I could easily get A. Do you guys see? Because you have A and then you have the side opposite. The only thing about it is you have to recognize that A would be an acute angle, so you would only use the quadrant 1 case. Does that make sense? And you can see it from the figure. The only other thing you could do, and I'm going to just go ahead and do law of cosines. So let's see if we can get A with law of cosines. What would we need? What's the formula? Inverse cosine of what? B squared, C squared minus what? A squared over 2 what? BC. Do we have all that? Sure we do. So if you're in doubt, just stick with what the book says. Just stay with law of cosines. Does that make sense? And then there's no ambiguity. You know it's the right angle, okay? So we would need inverse cosine. What was B? B we just got is 461.9. C is 600. A is 150. And then down here we have 2 times B times C, which is 600. Okay, I'm going to definitely simplify this inside here. Oh, wait, could I have just gotten C right there? Wait a minute. A squared B squared minus C squared. Yeah, I'm sorry. Why don't we just go ahead and get C, right? I'm being foolish here. So let's back up. How would you get C? Don't we have all that? Over what? 2AB. Just get C. That's easier. I'm sorry. That makes the whole problem easier. Actually, to be honest with you, that's better than doing law of sines anyway. You just go directly to C and then do 180 minus. Okay, so inverse cosine. Let me fix this. A was 150. B was 461.9. C was 600. Over 2 times A times B. Okay, now I'm going to clean up the inside. I mean, you can get A, but it's kind of a waste of your time. It's C that you need, right? $153.63. All right, good. Is C, right? I'm going to go back to the figure, take a real quick peek. How are you guys doing? So let me just stress this. This is the best way to do the problem, because once you got all the sides, of course you can get whatever angle you need with law of cosines, and you need C, because C is directly, C plus theta plus C is how much? 180. Do you guys see it? And so then you can get your theta and you can figure out what you need to turn. So 180. So then theta is going to be 180 minus C, which is 180 minus 153.63. How much? 26.37 degrees. So you'd say, oh, okay, to get back on course, I need to turn the boat 26.37 degrees. Does that make sense? Everybody got it? Okay. Now, of course, they want more from us because it's just an annoying problem, but I'm kidding. I guess this is stuff you might need to know. But it says, once the turn is made, how long will it take before the ship reaches Barbados if the same 15-knot speed is maintained? Okay. So what is this part B? They want to know if your rate is 15 knots, how long? You want the time. Okay, now I'm going to go back to my figure for a second for you guys to kind of see this. Let me actually move this, and I'll move the figure with it so you've got it. Here's this. I grab this figure. Okay, now I'm going to highlight this. We've turned, right? And now what I've just highlighted in red, do you guys agree that's the distance we need to travel now to get to Barbados? Am I right? Yes? How much is that distance? 461.9. So we know we need to go 461.9 nautical miles. Make sense? So how do you get time? Well, we know distance is what? Rate times time. We know the distance we need to travel already. The distance is what? 461.9, correct? We know the rate is what? 15, and now we're going to get the time. Make sense? So we'll have 461.9 would be equal to 15t. So to get t, take the 461.9 and divide it by 15. What are you talking about here? 461.9 divided by 15. How about 30.79 hours? Make sense? Okay. Everybody got it? Okay. All right, that is it for 9.3. And now we're going to move on to, last section is 9.4. It's super easy. Again, they give you the main formula for the test. They actually give you the main two, so that's great. You've got the formulas. The only thing you need to just memorize the pattern on the one. So let me stop and restart.